Okay. Good evening. Okay. 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 Right. So last day we started the construction rules of root locus. So in that we are discussing breakpoints. Breakpoints. It is a rule 6. I discussed it. What is a breakpoint? Simply breakpoint is nothing but what I told. Junction of poles. So breakpoint means simply the point at which two or more poles, the point at which two or more poles meet or directly locate at any location is called breakpoint. Listen carefully. You should listen, you should store everything in the mind, then only you can able to understand. Otherwise, it is very difficult. Root locus, not that much easy. So listen. Okay. You should read more also this chapter, then only can get it. Next, breakaway point I told. What is breakaway point I told? The point at which root locus branches. The point at which root locus branches moves away from the point, moves away from the point is called breakaway point. This is the standard definition. But according to local author books, simply moving away from the real axis, leaving the real axis. The point at which root locus branches leaving the real axis. The point at which root locus branches leaving the real axis. Real axis. So this is standard, this is local author books. Most of the local author given this. Next, break-in point. The point at which root locus branches enter into the point is called break-in point. According to local authors, the point at which root locus branches enter into real axis. Is called break-in point. Okay. So this is main definition. This is like local author books. Here main problem is, what is the main problem means? Sometimes they are asking questions from local author books. For example, if you see, with one more statement I'll tell, after that I'll take one problem, then we'll discuss. See, whenever root locus branches living or enter into real axis, whenever root locus branches enter or leaves, whenever root locus branches enter or leaves the real axis, then it should maintain, then the root locus branches should maintain, then the root locus branches should maintain angle of plus or minus 180 degrees divided by n. The root locus, whenever root locus branches enter or leaves the real axis, then the root locus branches should maintain the angle of plus or minus 180 degrees. Whenever enter or leaves, it should be calculated at the point of entering, at the point of leaving, it should be calculated angle by using plus or minus 180 degrees divided by n, where n is number of poles at that point, where n is number of poles at the break point, or at that point, where n is number of poles at that break point. Okay, na? So now listen. So I'll take one simple problem. Listen. Okay. One simple problem I'll take. So the root locus diagram shown in figure. The RLD is shown in figure. Here root locus branch exists. Here also root locus branch exists. So this is the diagram. This is the RLD. Here K0. At poles K is 0. Already I told at zeros K equal to infinity. At zeros K equal to infinity. This is the diagram. In case the question they will ask, first question for example, the breakaway points are, for example, this is -2. This is -4. First question, the breakaway points are, points is or whatever it is or. So what is the answer? Anybody? What are the breakaway points? Anybody? -2, -2, -2, -2, 4, -2, 4. See here, based on the option you have to select. If that fellow framed the question from standard books, in case that fellow framed the question from standard books, no doubt he will give the options like this. In case, so they'll give option A, -2, option B, -4, option C, like -2, -4, option D, something, none, for example, like this they'll give. So whenever they gives like this, the first priority is go for C, -2, -4. In case options are giving like A, in case that question they prepared from the local author books, that fellow will give option -2, -4, -6, like this, D none, or -infinity, -8, like this they'll give. In that case, what is the breakaway point? You select it -2. -2 is a breakaway point. So if -2, actually breakaway point moving away, here also moving away, here also moving away, here also moving away, both are breakaway points only. But local author books only they leave the real axis, they consider as a breakaway point. That is wrong actually, but we cannot write wrong. So you should select the answer. So that means first you observe the options and then select it. In case both are there, select the both. If it is not there, then first priority gives the leave the real axis. If single option is there, priority gives the leave the real axis. Single option is there, single breakpoint is there, first priority gives the what? Leaving the real axis. Leaving the real axis. First is 2. If it is not there, then select the what? Leaving the real axis. Leaving the real axis. Okay, na? This is the first priority. If it is not there, then this is second priority. Only leaving the real axis. Similarly, the break-in point is R, if you ask. So SB means standard books. If in case question from standard books, same thing, -2, -4, -2, 4, D, none, for example. What is the answer you'll select? What is the answer you select? C only. Here also select answer C only. Because select C only. Here also what happened? Break in. First enter into the point. Here enter into the point. Break in. Here also enter into the point. That means break in. Both are break in also. That means answer C. This is the first priority. Here, for example, local author books. If it is not there, B, -4, C, -6, D, none, for example. What is the answer you'll select? -4. Enter into the real axis, you select. -4. This is second priority. Enter into the real axis, local author. So based on the options, you proceed. Based on the options, you proceed. If in case both are there, select the both. If it is not there, so leaving the real axis, enter into real axis. Leaving the real axis is called breakaway point. enter into real axis is called breaking point. So be remember this. Why? Because these fellows are not following. Sometimes questions they are not preparing from the standard books. So that's a be careful. Okay, na? Okay. Okay. Next. Very good. Very good. Next. So whenever poles are leaving or entering, it should maintain the angle of what? Plus or minus 180 degrees divided by n. So here n is how many poles meeting? 2. That means it should leave with plus or minus 90 degrees. Even how many poles entering here? 2 poles. That means it enter into plus or minus 90 degrees. So be remember that. Okay, na? So this is about the break point. Next, procedure to find the location of the break. Actually, at the break points, the K value may be maximum and minimum. Maximum minimum means on the real axis. For example, here K0, 1, 2, 3, 4. Then after that, what? Leaving the real axis means in this region, here K is maximum. After that, the poles become the complex conjugate. Again, here what happened? K, for example, 10. K, for example, here 100. 100, 200, 300, here infinity. That means here minimum on the real. In this region, here value is minimum. Here value is maximum. That means generally at the break point, K value is minimum or maximum. So to find minimum and maximum, we require to differentiate the K value. At the break point, K value may be minimum or maximum on the real axis. At the break point, K value may be minimum or maximum, may be minimum or maximum. K value may be minimum or maximum. To get minimum and maximum value, to get minima and maximum value, along that line, K value minimum maximum along that branch, along the root locus branch, along the root locus branch. To get minima or maxima, to get minima and maxima, differentiate K. Differentiate K with respect to S and make equal to 0. Write the procedure. Procedure to find location of breakpoint. Procedure to find location of breakpoint. Step 1. Form the characteristic equation. Step 1. Form the characteristic equation. 1 plus G of S, H of S equal to 0. Step 2. Rearrange the above equation. Rearrange the above equation in the form of K equal to minus F of S. K equal to minus F of S. Step 3. Differentiate K with respect to S, make equal to 0. Differentiate K with respect to S and make equal to 0. And make equal to 0. Step 4. The roots of dk by ds equal to 0. The roots of dk by ds equal to 0 gives the valid and invalid breakpoints. The valid breakpoint is the one it should be on root locus branch. It should be on root locus branch. The valid breakpoint is the one, it should be on root locus branch. Or otherwise, what you have to do, no? Best to use this only. If it is on root locus branch, then it is valid. If it is not on root locus branch, then it is not valid. Otherwise, what you have to do, whatever the roots you are getting, that breakpoints, whatever you are getting, that you have to substitute in equation 2. Then if you substitute in equation 2, k should be positive. For valid breakpoint, but don't do this, wasting the time. For valid breakpoint, the k value in step 2 should be positive. When k 0 to infinity. In case range of k is 0 to infinity, the valid breakpoint, if substitute in step 2, k should be positive. In case k minus infinity to 0, then for valid breakpoint, k should be negative. In case k negative, but not required. Simply, if you are drawing the direct root locus, if the point lies on the direct root locus, it is valid. If you are drawing the inverse root locus, if that point lies on inverse root locus, then it is valid. It will come inverse root locus. No need to worry. Okay, na? Just observe it is there on the root locus branch or not. Root locus branch is there means it is valid. That's all. Note down one problem. Note down one problem. Find the location of breakpoints. Find the location of breakpoints. For g of s, h of s equal to k by s into s plus 2. Come on, do it. Sorry, first I'll solve it. Listen. First we'll go by procedure. After that, I'll tell the shortcut. Okay. First we'll solve by procedure. Solution. Form the characteristic equation. So 1 plus gh equal to 0. That is what I'll get earlier. So simply 1 plus k by s plus 2 equal to 0. Then characteristic equation is s square plus 2s plus k equal to 0. K equal to minus s square minus 2. Next, differentiate k with respect to s. Make equal to 0. What I'll get earlier? Minus 2s minus 2 equal to 0. Now find the roots for this. What is s? Minus 1. Is it valid or not? For that, represent the root locus branches. One pole at where? Origin. One pole at where? Minus 2. Is there root locus branch here? Take a point, count right. How many poles? Only one pole. One means odd. Odd means there exists the what? Root locus branch. Here exists the root locus branch. So where is the minus 1? Here minus 1. Is it valid or not? 100% valid because it lies on the what? Root locus branch. If it is on root locus branch, then valid breakpoint. So this is a valid breakpoint. That's all. It is a valid breakpoint. That's all. This is by the procedure. But simple shortcut is, listen. Simple shortcut is, instead of writing characteristic equation, again finding k and wasting the time, simply what I will say, listen. So what is given? G of s, h of s equal to what is given? K by s into s plus 2 given. Simply breakpoint equal to dk by ds equal to 0. Breakpoint is nothing but simply dk by ds equal to 0. Simply what you do, d by ds of. In place of k, put it 1. Don't, in case k replaced by 1. K replaced by 1. Remain terms as it is, you write. Don't consider k, remain terms as it is, you write. So don't consider k, and that means 1 by s square. Expand the terms, 2s equal to 0. Just differentiate, that's all. Differentiate, simple shortcut, differentiate. K replaced by 1. That's all. 1 by s square plus 2s. Now differentiate. Differentiation of u by v is what? Differentiation of u by v. Differentiation of u by v, tell d by dt of u by v means what? U dash into v minus u v dash divided by v square. U dash v minus u v dash divided by v square. Make equal to 0. And simply what I will say, breakpoint is nothing but u dash v minus u v dash equal to 0. That's all. Breakpoint is nothing but u dash v minus u v dash equal to 0. Breakpoint equal to u dash v minus u v dash equal to 0. Simply u dash v minus u v dash equal to 0. Come on, u dash. What is u dash here? 0. U dash is 0. So u dash, no need to write v, minus u into v dash. What is v dash? Tell 2s plus 2 equal to 0. That's all. So u dash 0 minus u into v dash 2s plus 2 0. S equal to what? Minus 1. It lies on the what? Root locus branch. It lies on the root locus branch. Here root locus branches exist. Where is minus 1? Here minus 1. So it is a valid breakpoint. That's all. In case here it is invalid. Here root locus branch exists na. So root locus branch exists na. So that means it is a valid breakpoint. That's all. It is a valid breakpoint. Okay na? Next, one more problem. MSQ select both. In case MSQ gives, select the both, no problem. In case here given like this, minus 2, minus 4, minus 6, select 2 and 4, no problem. We can put the again, we can give the complaint na. Okay. So Both you select. Okay. Next one. Fifth one. Next problem. Find the location of breakpoints. For G of S, H of S equal to. For G of S, H of S equal to K into S plus 2. S plus 4. Both are there, select the both so that if we don't give the answer, we can challenge the question. Okay. Come on, do it. Go by shortcut. Come on, dk by ds. Break point. dk by ds equal to 0. d by ds of s square plus 6s plus 8 by s square equal to 0. Come on, do it. U dash v minus uv dash. Come on, solve and tell the answer. Four by 3 now. Minus 1.33. 0 minus 2.66. So here, differentiate u dash means 2s plus 6 u dash into v means s square minus u s square plus 6s plus 8 into v means 2s. V dash means 2s equal to 0. Equal to 0. Now expand it. 2s cube 6s square minus 2s cube minus 12 s square minus 16s equal to 0. Now 2s cube cancelled. Now what happened? Minus 6s square minus not 6 under minus 6s square minus 16s equal to 0. S into you can write 6s minus 16 minus 6s minus 16. Find the roots for this. We'll get, I think, 0 comma minus 2.33 will get. 0 comma minus 2.33 will get. Is it valid or invalid? Check it. So 2 poles at origin. 1 0 at minus 2. 1 0 at minus 4. Where the root locus branch? Here no root locus branch. Here also no root locus branch, because if you take a point here 2, no root locus branch. But here if you take 1, 2, 3, so that means here root locus branches exist. 0, multiple poles are there. 100% it is a break point. What is the definition of the breakpoint? Two or more poles directly locate. No doubt it is a breakpoint. That means breakpoint 0 is correct. And minus 2.33 means that is also correct here. Because it is on the what? On the root locus branch. Minus 2.33 on root locus branch. That means both are valid breakpoints. Both are valid breakpoints. Now draw the root locus diagram, all of you. Draw the root locus diagram. Draw the root locus diagram. Come on. Number of asymptotes you tell. Number of root locus branches is 2. Number of not required root locus branches automatically will get. Number of root locus branches means what? Either poles may be greater than 0 or poles may be less than 0. Here poles equal to zeros. That means same, that equal to 2. Number of root locus branches is 2. So number of asymptotes 0. Whenever asymptotes are 0, angle of asymptotes and centroid not required. Number of asymptotes n equal to p minus z equal to 0. Number of asymptotes 0 means angle of asymptotes centroid not required. When number of asymptotes 0, number of asymptotes are 0, when number of asymptotes are 0, then angle of asymptotes and centroid are not required. When the number of asymptotes are 0, then angle of asymptotes and centroids are not required. Centroids are not required. When centroid required, centroid required only when the number of asymptotes more than or equal to 2. Centroid required only. Centroid required only when the number of asymptotes more than or equal to equal to 2. More than or equal to 2. Whenever more than or 1 also, if number of asymptotes 1, centroid not required because angle of asymptote is 180 degrees. 180 degrees means simply left hand side. We don't require angle of asymptotes. Okay, na? So we don't require centroid. Centroid not required when the number of asymptotes are less than 2. Less than 2 means centroid not required. Okay. Now draw the diagram, all of you. Draw the diagram, root locus diagram you draw. Draw the root locus diagram, all of you. Two poles at origin. One 0 at -2. 1 0 at -4. So here root locus branches exist. Now represent the breakpoint. Here one breakpoint is 0. Here one breakpoint is -2.33. -2.33. So now 2 poles as well as 2 zeros. Directly there are 2 poles, 2 zeros are there. That's why there is no asymptotes. Whenever number of poles equal to number of zeros, we don't require any extra zeros. We don't require any extra zeros at infinity. Poles equal to 0 means there is no more asymptotes, no more extra zeros at infinities. So now draw the root locus diagram. What is the root locus diagram? As k increases, the poles leaves the real axis here. The poles leaves the real axis. It cannot move right. It cannot move left because no root locus branch. It leaves the real axis. It's just like breakaway point. It leaves the real axis. Then what happened? It turned toward the left. It turned toward the left and enter at the break point. It turned toward the left. Enter at the break point. Why this? Use this. Okay. Right. So here enter. So it should be enter with what? Plus or minus 90. Because two poles are leaving, two poles are entering. Then one pole moves towards 1, 0. One pole moves towards 1, 0. Another pole moves towards another 0. Another pole moves towards another 0, occupies the 0. This is the root locus diagram. As k increases, the poles moves towards the zeros, towards the left side. So you will get the diagram like this. So this is also valid breakpoint. This is also valid breakpoint. This is the RLD. Why I drawn this diagram means sometimes in the exam they are asking, they'll give the transfer function. They'll give this transfer function k into s plus 2 into s plus 4 by s square they'll give. And they'll say the root locus diagram to the given transfer function is circle. They'll mention shape of the RLD also. It is a circle they'll mention. The center and radius of the circle is, they will ask. The center and radius of the circle is. So what they'll give? What they'll give means the open loop transfer function of a system. The open loop transfer function of a system is g of s h of s equal to k into s plus 2 s plus 4 by s square. The RLD is a circle. The RLD is a circle. The RLD is a circle. They'll mention shape of the diagram. You no need to worry. They'll mention the RLD is circle. The center and radius of the circle is, the center and radius of the circle is the center and radius of the circles are, the center and radius of the circle are. How to find the center, how to find the radius. You no need to draw any diagram. You no need to draw any diagram. Simple logic is center is nothing but not centroid. If you ask center, don't find centroid, Guruji. Don't find centroid. Centroid is different, center is different. Center for circle, you'll mention the shape of the RLD. Center is nothing but midpoint of the breakpoints. Midpoint of breakpoints. Center is nothing but midpoint of breakpoints. Center is nothing but midpoint of the breakpoints. How to find midpoint of the breakpoint? So what are the midpoint? One is 0 minus 2.33. 2.33 or 2.66? 2.66, nah, nobody telling. 2.66. Yes, sir, no, 2.66. This is 66. 2.66. So now, so what happened? 2.66. 0 minus 2.66 divided by 2. That means minus 1.33 is the center. Center, I can say center C is minus 1.33 comma 0. Center is minus 1.33 comma 0. That means where is the center? Somewhere here. The center here somewhere. This is center. Minus 1.33 comma 0. We want to put it otherwise simply minus 1.33 is the center. So center is minus 0.3. Midpoint of breakpoints. Midpoint you find, that's all. That is a center. What is the radius? Radius is nothing but radius is nothing but radius is nothing but distance between center to radius, center to break point. Distance between center to break point. Center to break point. Distance between center to break point. Distance between center to break point. Come on, center to break point. What is the distance? For example, what is the distance? What is the distance tell? Or what is the distance tell? So 0 to here means what is the distance? 1.33. Or 1.33 minus 2.66. This is minus 2.66. What is the distance tell? What is the distance tell? R equal to 1.33. Center to any breakpoint. Distance between center to any breakpoint. Center to breakpoints. Distance between center to breakpoint. So it is nothing but R equal to 1.33. That's all. Like this you find the what? Center and radius of the circle. Like this you find the center and radius of the circle. Okay, na? So generally this question they will ask when shape of the RLD is circle. Otherwise they don't ask. Okay, na? Okay. If more than 2-3 breakpoints is there, how can you get the circle? When you will get the circle, only 2 is there possible. If 1000 is there possible, what man? Right, next. Next question. Find the location of breakpoint. So G of S, H of S equal to. Come on, do it. Find the breakpoints. Find the location of breakpoints. All these are non-unity only. Yeah, this is non-unity. GH means non-unity. Either unity or non-unity, both are same. There is no difference in drawing the diagram when unity or non-unity. That is for only type and steady state errors. Remain cases Either unity or non-unity, immaterial. The procedure of drawing the diagram same. H is there means non-unity. I told very clearly. Again, you are asking, give one example for non-unity. Kya bhaiya? Unity, non-unity. First class I told. H of S, one is there, then unity. GH given means non-unity. One day attending, one day not attending the class. Even attending, one listening and forgetting. Listen and forget. Then what you will get there? Come on, get the answer. Find the break point. Karthik, tell, what is your doubt? Karthik. Karthik. Right. So, find the break point. Listen, after the class, you read 2-3 times at least you read. Anything difficult means not worked in that area, that's all. There is nothing difficult. Difficult means not known, not work in that area. If you don't work lifelong, it is difficult only. You should work more, then it will become very easy. You spend a more time, any topic, anything, it will become easy only. Childhood, ABCD is also very difficult. We are unable to write. But as you work, it become very easy. Same thing. You should work it. Come on, find the break point. There is no alternate for the hard work. That's all. You have to go on, do the hard work. Automatically, you can understand anything. You should read. You should work. dk by ds equal to 0. d by ds. Bolo. S square plus 6s plus 8 by s equal to 0. Come on, tell the break points. Come on, do it. So what you will get? U dash means 2s plus 6 into v. V means what? S cube. Minus s square plus 6s plus 8 into 3s square equal to 0. Come on. 2s power 4 plus 6s cube minus 3s power 4 minus 18s cube minus 24 s square equal to 0. Now simplify this. To simplify, what we will get? Minus s power 4 minus 12s cube minus 24 s square equal to 0. S square, take it common. Then what you are getting? S square minus s square minus 12s minus 24. Find the roots for this. To find the roots, s equal to 0 comma 0 means you can write only 1 0. 1 point act as a 1 break point. That's all. Don't write 0 comma 0 comma 0 comma 0. Don't write it. 0 means 0. Only 1 point. Next, minus 9 point, I think 46. And another one, minus 2.53. You find the roots. Minus 2.53. Come on. So which are valid, which are not valid? Draw the, identify which are valid, which are not valid. So here 3 poles at origin. Multiple poles at any location, that is by default breakpoint. Multiple poles located at any location, no need to calculate. Blindly we can say it is a breakpoint. I can say blindly 0 is a breakpoint without any calculation. 3 poles. What is the definition of breakpoint? Poles directly locate also breakpoint, meet also breakpoint. I told again, same thing they will ask. They're not listening. minus 2. Listen. Last day I told breakpoint definition. Today I told breakpoint definition. Again in the question, repeated poles how breakpoints are. Right. So now tell, this is breakpoint. Here, is there root locus branch here? No root locus branch. Here, root locus branch exists. Because if you take a point, how many poles? 3 poles. 3 poles means root locus branches exist. Here, no root locus. Why? Bolo. 1, 2, 3, 4. 1, 2, 3, 4. Means what? 4 means even, no root locus. Here, what happened here? Count it. 1, 2, 3, 4, 5. 5 means root locus. 5 means root locus. Here root locus exists. Here root locus exists. Root locus is exist. Yes or no? So now tell. So what are the valid breakpoints? Tell. 0 is a valid breakpoint. Next, minus 9 point. 9 point means here somewhere. This is minus 9.46. It is a valid breakpoint. Minus 2.53. It is an invalid breakpoint. It is not on root locus. Minus 2.53 is an invalid breakpoint because it is not on root locus. Right. Centroid minus 1.33. Calculate correctly. Right. Next, come on. Now draw the root locus diagram. Number of asymptotes. Bolo, number of asymptotes. Number of asymptotes. N equal to P minus Z. 3 minus 2. Angle of asymptotes. Angle of asymptotes. Theta equal to 180 by P minus Z. P minus Z is 1. That means what is the angle of asymptote? 180. Centroid not required. Centroid required only when number of asymptotes more than or equal to 2. Centroid not required. Come on, draw the RLD. Draw the RLD. You draw the root locus diagram. Draw the root locus diagram. Draw the root locus diagram. Come on. So here 3 poles lies at origin. K also 0. 1 0 at where? Minus 2. 1 0 at where? Minus 4. Come on, identify root locus branches. Here there exists a root locus branch. Here no root locus. Here there exists a root locus branch. Next, here one breakpoint. At origin one breakpoint. Breakpoint equal to 0. Another breakpoint here, minus 9.46. Minus 9.46. Now, listen, draw the diagram. Number of asymptotes 1, angle of asymptote 180. 1 minus 9.46 minus 9.46. 180. 1 minus 9.46 minus 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 180. 1 minus 9.46 That means at 180 degrees, there is a 0 at 180 degrees. Minus infinity, k equal to infinity. This is the asymptote. So at 180 degrees, there is a 0. At 180 degrees minus infinity, there exists a 0. There exists a 0. Now draw the RLD. Draw the root locus diagram. So what happened here? 3 poles lies at origin. So 3 poles means it should leave the real axis. 2 poles, 1 pole may go like this, but 2 poles should leave the real axis. Na? So leaves the real axis with an angle of what? Plus or minus 180 degrees divided by n. How many poles are there? How many poles are there? 3 poles. So that means n equal to 3. That means leaves the real axis with plus or minus 60 degrees. The poles leaves the real axis with plus or minus 60 degrees. The poles leaves the real axis with plus or minus 60 degrees. One pole leave with plus 60 degrees like this. One pole leave with plus 60 degrees like this. Another pole leave with minus 60 degrees. Another pole leave with minus 60 degrees. One pole leave with plus 60, another pole leave with minus 60. One more pole leave along the left side. One more pole moves along the left hand side. All the 3 poles should leave the or should move the point by maintaining equal phase shift. 3 poles should leave from origin by maintaining equal phase shift. So what is the phase shift here? Tell. So here 3 poles are there. One pole 60. Another pole minus 60. Another pole left side like this because root locus branch is there. What is the phase shift to tell? Check the phase shift. What is this phase shift? Come on. 60 to minus 60, 120. This is 180 degrees na? 60 to 180, what is the phase shift? 120. 180 to minus 60, what is the phase shift? 120. That means what? All the 3 poles should leave from the point by maintaining equal phase shift. By maintaining equal phase shift. If n poles are there, n poles should leave the point by maintaining equal phase shift. For example, there are 4 poles here. There are 4 poles, for example, here. 4 poles are there, for example. How it leave? It should leave with by maintaining plus or minus 180 by n. N is how much? 4. Means it should leave with plus or minus 45 degrees. So one pole with plus 45. One pole with plus 45. Plus 45 like this. This is plus 45. Another pole minus 45 like this. This is minus 45. And remain 2 poles. Remain 2 poles. How it move? What is the phase shift between these two? What is the phase shift? 90 degrees. Phase shift between these two is 90. Add 90 here again. Add 90 here again. 90 should add. If you add 90, what happened? If you add 90, what happened? 45 plus 90, 135. It should move with 135 degrees. 135 degrees. Again add 90. Again add 90. Add 90. That means it leave. It leave with what? Bolo. Here also same 90. Here also same 90. So much? 225 degrees. 225 degrees. That means all the poles should leave from the point by maintaining equal phase shift. You take any 2 poles. You take any 2 poles, the phase shift should be same. Any 2 poles, n poles are leaving from the point means all the n poles should leave by maintaining equal phase shift. By maintaining equal phase shift. Now draw the diagram. Come on, draw the diagram. Draw the diagram. Come on. What is the diagram? So as k increases, these two poles initially moves right, but one pole it comes to left. It will go on, moves to left. It occupies the zero. When occupies the zero, when k equal to infinity. One pole gone. One pole, 1 0 completed. Remain how many poles are there? 2 poles. How many zeros are there? 2 zeros are there. This will turn towards the left. Enter at the break point. This will turn toward the left. It will turn toward the left. Enter at the break point like this. Enter at the break point. This is also turn toward the left. Enter at the break point. Both the poles turn toward the left. Enter at the break point. Enter at the break point. Both the poles turn toward the left. Both are turned toward the left. Enter at the break point. Then one pole. This is the pole's path. This is the poles only. Root locus branch means pole's path. This is the pole's path. So then once enter, how many poles enter? 2 poles. One pole moves towards 1 0. Another pole moves towards another 0. Occupies 0 when k equal to infinity. This pole moves left. Occupies 0, k equal to infinity. This is the root locus diagram. This is the root locus. It is not a circle shape. Look carefully. It is not a circle shape. Okay. Next problem. Next rule. So this is about the breakpoints. Next, 7th rule. Intersection point with imaginary axis. Rule 7. Intersection point with imaginary axis. Intersection point with imaginary axis. How to obtain intersection point with imaginary axis? Anybody? How to obtain intersection point with imaginary axis? By using RH criteria. By using RH criteria. Very good. Intersection point with imaginary axis is obtained by RH criteria. Intersection point with imaginary axis is obtained by RH criteria. Step 1. Form characteristic equation. 1 plus g of s h of s equal to 0. Form the characteristic equation. G of s h of s equal to 0. Step 2. Step 2. Write the Routh tabular form. Write the Routh tabular form. Write the Routh tabular form. Step 3. Find k marginal value. Find k marginal value. Step 4. Form auxiliary equation. Form auxiliary equation. Roots of auxiliary equation is a intersection point with imaginary. Roots of AE means auxiliary equation. Roots of auxiliary equation is a intersection point with imaginary axis. Intersection point with imaginary axis. For valid intersection point, K marginal should be positive. For valid intersection point, K marginal should be positive. When K greater than 0. When K increases from 0 to infinity. So this is the procedure. Note down one problem. RH criteria we knows na. RH criteria we knows already completed na. So solve one problem. Find the intersection point with imaginary axis. Find the intersection point with imaginary axis. G of S, H of S equal to K by S into S plus 2 into S plus 4. Come on, do it. Venkatesh. Venkatesh. Any doubt? Sri Charan.
Oh, sir.
Tell first.
Sir, in 5F, sir, I think 5F
tell.
or 6. Sir, here we should take 1 plus GS of H, G of S, H of S, no, sir.
Huh?
1 plus G of S, H of S, we should take, no, sir.
I told na simple shortcut. How to find breakpoint, simple shortcut.
Okay.
K replaced by 1, I told na.
Okay. Yes, sir. Yes, sir. Sorry, sir.
Next, come on. Characteristic equation. 1 plus K by S plus 4 equal to 0. Then what is the characteristic equation? S cube plus 6s square plus 8s plus K equal to 0. Now get the answer. S cube, S square, S power 1, S power 1. Next 8, next 6, next K. 48 minus K. 48 na minus K divided by 6. Now here K. So what you have to find? First K marginal value. For K marginal value, S power 0 coefficient not consider. I already told. Make equal to 0 for marginal stable. That means K marginal equal to 48. Form auxiliary equation. 6s square plus 48. 6 1 ja, 6 8 ja. So S equal to what? Plus R minus J root 8. Is a valid intersection point because K marginal is positive. as k marginal is positive, range of k 0 to infinity default. So it is a valid intersection point with imaginary axis. It is a valid intersection point with imaginary axis. That's all. Next, last rule. Rule number 8. Angle of departure and arrival. Angle of departure and arrival. Angle of departures and arrivals. Departure means leaving. Departure means leaving. Arrival means entering. Arrival means coming, entering. Departure, moving away. So this angle of departure, arrival required to calculate only at complex poles. The angle of departure and arrival. Angle of departure. For real poles, no need to calculate. For real poles, by looking at moment, we can identify angle of departure. For example, here, one pole here. What is the angle of departure? Tell. Where is the root locus branch here? That means it should move to left. That means angle of departure is 180 degrees. In case I will put one more pole here, for example. One more pole I will put here. One more pole I will put here. What is the angle of departure of this pole? Here there exists a root locus branch. So this is coming like this. For this pole 180. For this pole it should move right. That means angle of departure is 0 degrees. So that means for real poles, real zeros, we can identify angle of departures and arrival simply by observing the what? The moment along the real axis. For real poles, real zeros, directly we can identify by observing the what? Moment of the pole or zero on the real axis. That's why this we have to calculate only for complex poles and complex zeros. Angle of departure is calculated at complex poles. At complex poles. And angle of arrival is calculated at complex zeros. Angle of departure is calculated at complex poles. Angle of arrival is calculated at complex zeros. For example, here, simple now, what is angle of departure? Tell. For example, here complex poles are there. This is the complex poles. So what happened? As k increases, this pole should move some direction. As k increases, this pole should move some direction. As k increase, for example, here k0. Here k0. As k increase, should move some direction. It should move some direction. So it should move some direction. Yes or no? With what angle the pole leaves from the initial position given by angle of departure? With what angle the pole depart from the initial position given by angle of departure? Given by angle of departure. Given by angle of departure. Okay, na? What is angle of arrival? For example, if I take here complex zero, what is the angle of departure? With what angle the pole leaves from the initial position, leaves, depart from the initial position is called angle of departure. What angle of, with respect to 0 degrees? This is 0 degrees with respect to 0 degrees. What angle of arrival? For example, this is 0 degree with respect to 0 degrees only. What angle of arrival? So here, the pole should occupy the 0. No? The pole should come in some direction, it should occupy the 0. The pole should be occupies the zeros. With what angle? For example, this pole is coming like this. With what angle the pole arrives, terminates at a complex 0 given by angle of arrival. With what angle the pole arrives, terminates at a complex 0. With what angle the pole arrives, terminates with a complex 0 given by angle of arrival. Given by angle of arrival. With what angle the pole arrives, terminates near the complex 0 given by angle of arrival. That's all. Given by angle of arrival. So first angle of departure. So what is arriving here? Pole is arriving. Here arriving pole. Here what is departing? Pole is departing. So both are related to pole only. Departing pole, arriving also pole. But arrival calculated at complex 0. Departure calculated at complex pole. Complex pole. So write it, angle of departure. The angle of departure, write it. Right. The angle of departure. The angle of departure. Angle of departure gives that with what angle the pole depart or leaves from the initial position. So angle of departure gives that with what angle the pole leaves from the initial position. What is the formula for angle of departure? 180 degrees plus angle GH. At positive, generally you can calculate here also, but better calculate at positive imaginary, it becomes very easy. At positive imaginary complex pole. At positive imaginary complex pole. Phi d equal to 180 plus angle GH at positive imaginary complex pole. So be remember this. There is one more formula also, that is pi d equal to 180 minus pi. Both the answers are same, or 180 minus pi, where pi equal to sum of angles contributed by poles minus sum of angles contributed by zeros. Pi d equal to 180 minus pi. Better use the first one. First one is very easy. So better use first one. I'll use first one only. But be remember second one also. 180 minus pi, where pi equal to sum of angles contributed by the poles minus sum of angles contributed by the zeros. Okay, na? Next. Angle of arrival. Angle of arrival. The angle of arrival gives that the angle of arrival gives that with what angle the pole arise or enter the complex zero. Pole arise or arise the complex zero, enter the complex zero. Complex zero. The pole arrives, terminates, enter the complex zero, whatever it is, or end at complex zero. So what is the formula for angle of arrival? Phi A equal to 180 minus angle of G of S H of S at a positive imaginary complex pole, complex zero. We can calculate in another also, negative imaginary also, but positive imaginary is easy. At a positive imaginary complex zero. Or phi A equal to what? 180 plus pi. Where pi equal to sum of angles contributed by the poles minus sum of angles contributed by the zeros. Where pi equal to sum of angles contributed by the poles minus sum of angles contributed by the zeros. Very good. Right. Now note on the problem. Note on the problem. Calculate the angle of departure at a complex pole. Calculate the angle of departure at complex poles to the given system. G of S, H of S equal to K into S plus 2, S plus 4, S square plus 2S plus 2. Come on, do it. So now listen, it is just like I'll do the problem. First calculate angle GH. Angle of first poles and zeros you represent. So two complex poles, -1 plus or minus J1. -1 plus J1 minus J1. Here K0. Next 1 0 at where? -2. Next one 0 to -4. So where we should calculate at this point, this is the positive imaginary pole. At this point, you have to calculate angle of departure. What is that location? -1 plus J1. So angle of G of S, H of S, you have to find at S equal to -1 plus J1. That equal to angle of K, angle of S plus 2, angle of S plus 4, angle of S plus 1 minus J1. Roots you write denominator. Angle of S plus 1 minus J1. Angle of S plus 1 plus J1. Angle of S plus 1 plus J1. Now come on, substitute -1 plus J1. Angle of K. Here substitute S equal to -1 plus J1 plus 2. Angle of -1 plus J1 plus 4. Angle of -1 plus J1 plus 1 minus J1. Angle of S place, you put it -1 plus J1 plus 1 plus J1. Now what happened? -1, this cancel. Here -1 cancel. Then if you write it, angle of K, angle of what you are getting? 1 plus J1. Angle of here what you are getting? 3 plus J1. Divided by angle of 0, angle of J2. So come on, write how to find angle. Tan inverse of, I told in the last day, based on which region the point exists, you have to write the angle. If it is the first region, simply tan inverse of imaginary part by real part. Second region, 180 minus tan inverse. Third region, 180 plus tan inverse. Fourth region, minus tan inverse of imaginary part by real part. Angle of K is 0. Plus angles are added or subtracted. Angle of K 0. Angle of tan inverse of 1 by 1 means how much? 45 degrees. Imaginary part 1, real part 1. Tan inverse 1 by 1 means 45 degrees. Tan inverse of imaginary part 1, real part 3. Tan inverse 1 by 3 is, I think, 18.43 degrees. Divided by angle of 0, 0 degrees plus angle of J2, 90 degrees. Tan inverse of imaginary part 2 divided by real part 0. 2 by 0 infinity. Tan inverse infinity is 90 degrees. Now solve this. 45 degrees. 18.43 degrees. Minus 90 degrees. So what is the answer? Minus, I think, 26.57 degrees. Minus 26.57 degrees. Is it correct? Yes, correct. Now find, this is what? Angle GH. It is a angle GH. It is angle GH. G of S, H of S. Now get the answer. Pi D. What is the formula for pi D? 180 plus angle GH. 180 plus or minus? 180 plus angle GH. So that means 180 minus 26.57 degrees. That means 153.43 degrees. 153.43 degrees. That means if you ask what is angle of departure, means plus or minus 153.43 degrees. This is plus now. At this pole minus, because mirror image. Here plus means here it should be minus. Plus or minus. Now draw the root locus diagram. For example, here number of poles equal to number of zeros. Here number of poles equal to number of zeros. Why? Because there are 2 poles are there, 2 zeros are there. Here root locus branch exists. Root locus branches exist. Here angle of departure, how much you got? Tell 153 degrees plus 150. This is 0 degrees. This is 0. From 0, you draw the 153 degrees. This is 153 degrees. Plus 153 degrees. Approximately, I'll write. plus 153 degrees. 153 degrees. So same, it should be symmetrical. Now that means you should get like this. That means what is the angle here? Tell this should be minus 153 degrees. Minus 153 degrees. It should be minus 153 degrees. Minus 153 degrees like this. Then what happened here? There is a break point. You calculate in your home. You check the break point. You find it. I already told how to find the break point. There should be a break point here. I think break point is minus 2.61. I think you check in your home. I think break point is minus 2.61. You will get it. Check it. Then it leaves and enter at the break point like this. This is also leaves, enter at the break point like this. Both the poles leaves, enter at the break point. Simple logic. Poles should move toward the zeros by maintaining symmetric about real axis. So like this, this is angle of departure. This is angle of departure. So here k equal to infinity. Here k equal to infinity. This is the root locus diagram. So angle of departure is plus or minus 153.43 degrees. Okay, like this you have to calculate angle of departure. Same way you calculate angle of arrival. Come on. Same way you calculate angle of arrival. Come on, next problem. Calculate angle of arrival. Calculate angle of arrival at complex zeros. To the given system. G of s, h of s equal to k into s square plus 2s plus 2 divided by s plus 2 into s plus 4. Come on, do it. Sorry. You solve it. You try to solve in the break time. You try and take the break. 5 minutes, solve this problem. That same procedure. Angle GH also same. Where you have to calculate. So where are the complex zeros here? What is the complex zero? Minus 1 plus or minus j1. This is minus 1, here k infinity. One pole at minus 2. One pole at minus 4. K0, K0. Here root locus branches exist. So calculate at this 0, minus 1 plus j1. You calculate angle of g of s, h of s. At s equal to minus 1 plus j1. Come on, do it. You solve it, take the break. 10 minutes break you take. After that, we'll continue. Take care. Right. So what is the answer we got? What is the answer? 206, 153, 243. You'll get the same answer. Just a direction change. You'll get the same answer. Angle of K, angle of S plus 1 minus J1. Angle of S plus 1 plus J1 divided by angle of S plus 2, angle of S plus 4. Come on, angle of K, substitute minus 1 plus 1, it will become 0. You substitute minus 1 plus J1, it will become J2. Here substitute minus 1 plus J1, it will become 1 plus J1. Substitute here minus 1 means 3 plus J1. Then you will get the answer 0 degrees plus 0 degrees plus 90 degrees divided by 45 degrees plus 18.43 degrees. So 90 minus denominator, angles comes to numerator, minus sign, minus 45 degrees minus 18.43 degrees. So 26.57 degrees. Then what is the formula for angle of arrival? 180 minus angle GH. 180 minus 36.57. That means 153.43 degrees. So answer is this or minus 153 point. So that means angle of departure equal to what? Angle of arrival. If I draw the diagram here, as K increases, both the poles move in opposite direction. Both will collide. Here you will get the break point. Same break point here also. Whatever you got the answer, same answer you will get, minus 2.61, I think. Then leave the real axis. Then it moves towards the 0 and arrives the pole with the angle of plus 153. Arrives. This is also same. Arrives with the angle of minus 153. So this is the diagram. So shape of the diagram, both are same. Check it. This is the diagram. What is the difference? Tell direction. Only difference is direction. Shape of the diagram is same. There is no difference in the shape. Only direction is different. Here direction is like this. Only direction is opposite. So that means what do you understand? Tell here. What do you understand? Whenever what he did, what is the difference between transfer function? Same. Just I interchange the poles and zeros. Just I interchange the poles and zeros. Whenever all the poles and zeros are interchanged, whenever all the poles and zeros are interchanged, whenever all the poles and zeros are interchanged in the transfer function, then angle of departure equal to angle of arrival. Then angle of departure equal to angle of arrival. And breakpoints are same. Angle of departure equal to angle of arrival and breakpoints are same and shape of the diagram also same. Shape of RLD is same except the direction. Except the direction. Only direction only different. Remain everything is same. So be remember, whenever all the poles and zeros are in the here, what happen? Poles I consider as zeros, zeros I consider as poles. So if interchange poles and zeros, here I change, na. So if interchange, dekho here, poles are here, what happened? S square plus 2s plus 2. That I consider here 0. So poles and zeros are interchanged. Then angle of departure equal to angle of arrival. Break-in point equal to breakaway point. Shape of the RLD also same. Shape of the root locus diagram also same. That's all. Except the direction. So these are the construction rules of root locus. So rules are completed. Now we'll solve the problems. So total 8 rules it should be in the mind. First one symmetrical, second one is number of root locus branches, third one real axis root locus branch, fourth one asymptotes, fifth one centroid, sixth one break point, seventh one intersection point with imaginary, eighth one is angle of departure and arrival. Everything should be in the mind. Now note on the problems. Draw the approximate root locus diagram, or simply draw the root locus diagram. Draw root locus diagram. Draw root locus diagram and discuss the stability. And discuss the stability. For G of S, H of S equal to first I'll take simple problem. S into S plus 2. Come on, write the 3 steps. Write the procedure. So just remember this procedure, you can construct. Step 1. Identify root locus branches and breakpoints. Identify. First step, root locus branches and breakpoint. Second step, calculate angle of asymptotes. And centroid. If required, calculate angle of departure and arrival. Step 3. Step 3. Vary the K value. Vary the K value. from 0 to infinity. Vary the k value from 0 to infinity and identify the path. Identify the path from poles to zeros. Such that root locus diagram should be symmetrical about the real axis. Such that root locus diagram should be symmetrical about real axis. Okay, that's all. Come on, do it now. Come on, do it. Identify the root locus branches and breakpoint. Come on. Represent the poles and zeros in this plane. One pole at s equal to 0. One pole at s equal to -2. K equal to 0, k equal to 0. Here root locus branches exist. So is there here breakpoint? Calculate, no doubt. Two poles adjacent root locus branch is there means breakpoint is exist, no doubt. Why all these things? Find the breakpoint. Come on, find the breakpoint. D by ds of what? 1 by, already I solved this. S square plus 2s equal to 0. U dash means 0. U into V dash 2s plus 2 equal to 0. So s equal to what? -1. So here -1 is a breakpoint. So first step completed. So root locus branch breakpoint. Breakpoint is valid. Breakpoint is a valid breakpoint. Next, calculate angle of 19th page. Right. Next, calculate angle of asymptotes. Calculate angle of asymptotes and centroid. Come on, step 2. This is step 1. Step 2. Number of asymptotes n equal to p minus z. 2 minus 0 is called 2. Number angle of asymptotes. I told formula, remember? Simple formula, actually 2q plus 1. Simply what I told, 180 by p minus z. P minus z is 2. So 90. Multiply with odd number. 90 into 1, 90. 90 into 3, 270. Multiply with odd number. Multiply with odd number. Next, centroid. Sum of real part of pole. What is the real part of pole? -2. Real part of 0, 0 divided by 2. So that means centroid is -1. Now draw the root locus. There is no complex poles, complex zero. So no angle of departure, no angle of arrival. Now draw the root locus diagram. Draw the RLD. Right. One pole at origin. K equal to 0. One pole at what? -2. K equal to 0. Here root locus branches exist. Breakpoint is -1. Centroid also -1 only. Centroid also -1. So with respect to centroid, you should draw angle of asymptotes. What are the angle of asymptote? 90 to 70. Draw the angle of asymptotes 90 and 270. Come on. Draw the angle of asymptotes 90 and 270. So like this. Actually, angle of asymptotes should draw with a very light line. Angle of asymptotes should be drawn with very light line. Okay, I'll draw with this color. So along the 90 degrees, there exists 1 0. Along 90, there exists 1 0. Where K equal to infinity. Along 270, there exists another 0. Where K equal to infinity. After representation of asymptote, count the number of poles, how many? 2. Count the number of zeros, how many? 2. After representation of asymptotes, the number of poles must be equal to number of zeros. 2 poles, 2 zeros. Now draw the RLD. Now draw the root locus diagram. This is J omega. As K increases, what happens? Both the poles move in opposite direction. Both are moving in opposite direction. Then both the poles, what happen? Meet at the breakpoint. Both the poles meet at the breakpoint. How many poles meet? 2 poles meet. Once it meet, it leaves the real axis. It leaves the real axis with plus or minus 90. Then along the asymptote, it will go. Enter into asymptote along 90. It will move along the asymptote and occupies the 0. This pole also moves along the asymptote, occupies the 0. When K equal to what? Infinity. When K equal to infinity. This is the root locus diagram. This is the root locus diagram. Okay. So this is the root locus diagram. So now come on. What is the system? Stable or unstable? You have to find the stability. So see, when K equal to 0, the poles lies on imaginary axis. That means it is not stable. It is just like marginal stable. But still we don't consider for marginal stable. Marginal stability, the poles on imaginary we have to consider. Okay, one way it is marginal stable only, no doubt. So K equal to 0, it is not stable. K slightly greater than 0. What happened? The pole comes to left. This pole already in the left. Both the poles lies in the left, stable. Still increase, both are in the left, still stable. Still increase, both are left, stable. Still increase, both are left, stable. Up to what it is left? Up to infinity, it lies in the left only. Up to infinity, poles lies only in the left hand side. Poles lies only in the left hand side. That means K greater than 0. Then I can say that the closed loop system is stable because complete root locus branch lies in the left hand side only. For whatever the values of K, the root locus branches lies in the left hand side. For all that K values, the system is stable. For whatever the values of K, the root locus branches lies in the left hand side. For all that range of K values, the system is stable. So here what happened? K greater than 0. K greater than 0, the branches completely lies in the left, then the system is stable. Then the system is stable. Total all the values of K greater than 0, the system is stable. K greater than 0, I can say this system is stable. ठीक है ना? K greater than 0, the system is stable. Next one. Next. So what are the different natures the system is having? What are the different natures the system is having? I discussed in the time domain analysis. What I discussed? Whenever any two poles lies on the negative real axis at different locations like this, what is the nature tell? Overdamped. I told it. It is a overdamped nature. Zeta is greater than 1. Whenever two poles lies on the left hand side at the same location repeated, then it is called critical damped. Critical damped. Then zeta equal to 1. Zeta equal to 1. Whenever both the poles lies in the left hand side, which are complex conjugate, then I can say it is what? Underdamped nature. It is called underdamped. Underdamped. I discussed already. Zeta greater than 0, less than 1. Underdamped. Whenever poles lies on imaginary axis, like this, then it can say it is what? Undamped. It is called undamped. Undamped. So zeta equal to 0. It is called undamped. Zeta equal to 0. That means based on the position of the poles, we have to identify the nature of the system. Based on the position of pole, you have to identify the nature of that is the advantage of root locus. The main advantage of the root locus is we can decide what is the nature of the system. That is the advantage. We can decide the nature of the system. Okay? Listen. We can decide the nature of the system. Now listen. See here, listen Bhaiya. When K slightly increase, what happened? Tell. The pole comes to left. Here one pole, here one pole. Which is what? Both two poles lies in the left hand side. Different location. What is the nature? Overdamped. Still K increase. What is the nature? Overdamped. Still K increase. What is the nature? Overdamped. Still K increase. What is the nature? Because two poles on the negative real axis, different location. What is the nature? Overdamped. Up to meet at the break point. That means this total range for what? Overdamped. OD means overdamped. What is zeta tell? Zeta greater than 1. What is the nature tell? Overdamped nature. Remember da? Nature of the overdamped system. Remember da? It is rising and then exact nature. Decays exponentially. Large time constant. This is the nature of overdamped. Once meet at a particular point, then it is called critical damped system. Then it is called critical damped. Critical damped means CD. CD means critical damped. Then it is called critical damped. What is the zeta? Zeta equal to 1. What is the nature? What is the nature of critical damped? Tell. The nature of critical damped system. What is the nature? Tell. It is increased, then decreased like exponentially. It is increased and decreased like exponentially. This is overdamped nature. It is overdamped nature. So still K increased, what happens? So what happened? The poles are complex conjugate. Still K increased, the poles are complex conjugate. Means this total range for what? Underdamped system. Underdamped. Underdamped. What is zeta? Greater than 0, less than 1. What is the nature tell? The nature is decreasing amplitude oscillations like this. Decreasing amplitude oscillations. It is an underdamped system. It is an underdamped system. So decreasing amplitude oscillations like this. So that means this particular system having what? Overdamped nature, critical damped nature, underdamped nature. But here also underdamped. Underdamped. But it is not having the undamped nature. Undamped means pole should come on imaginary axis. No pole coming on imaginary. Two poles should come like this. Two poles should come like this. Then we can say it is a what? Undamped system. But here no poles are coming on imaginary. That means this system having the what? Overdamped, critical damped and underdamped nature. The above system is having overdamped, critical damped and underdamped nature. But not undamped. Nature. But not undamped nature. Now, what is the K values for different natures here? We want K values. So, I want K values for overdamped, critical damped and underdamped natures. So, I want K values for different natures. How to find K values? So, to find K values for different natures, we require to find K value at the breakpoint. Here you have to find K value. You have to find K value here. How to find K value at the breakpoint? K value at the breakpoint. How to find magnitude condition? I already told. K value at the breakpoint you can find by using magnitude condition or product of lengths. Product of lengths is very easy here. K equal to product of lengths. From this point to pole, what is the length? This is 0. This is -1. What is the length? 1. Year to year length how much? 0, year 1. What is the length? 1 unit. So 1. 1 to 2. What is the length? 1 to 2? 1 unit. So 1 into 1 divided by no zeros are there. You should not consider infinite zeros. You should consider only finite zeros. So there is no finite zero. So that means denominator 1. So what is K? 1. K equal to 1. So that means K value is 1. Or this is by using product of lengths. Even magnitude condition also gives same magnitude condition. What is the magnitude condition? Magnitude of K by S into S plus 2. At S equal to what is the break point? -1. No? This is -1. -1 equal to 1. So K by S into S plus 2 at S equal to -1 equal to 1. Now substitute S equal to -1. So -1 plus 2 equal to 1. Then solve it. What you are getting? Come on, K by -1 plus 1. K by -1 plus 1 equal to 1. What is the answer? K equal to 1. The answer is K equal to 1. The K value at the break point. So that is K equal to 1. See, both are same. Either use product of lengths or magnitude condition. The answer is not going to be changed. Both are same. The answer is not going to be changed. Now come on. Get the answer. Now get the answer for overdamp. Here K equal to 1. Here K equal to 0. Here K 0. Here K 0. Yeah. Here K 0. here K0, here K equal to 1, here K0, here K equal to 1. What is the overdamp tell? Year to year overdamp. Year to year, same. So what is the overdamp tell? K greater than 0, less than 1, the system is called overdamped system. Overdamped system. K equal to 1, 2 poles at -1, na? K equal to 1, critical damped system. Critical damped system. Critical damped system. K greater than 1, overdamped system. Sorry, underdamped. Year to year, underdamped, na? So, underdamped system. K greater than 1, the system is called underdamped system. K greater than 1, it is called underdamped system. Like this, you have to identify the what? Range of K value for different nature of the systems. For different nature of the systems. Even if you have any doubt, you substitute these values, you will get the same nature. For example, K equal to 1, the system should be critical damped. Listen, for example, K equal to 1, system should be critical damped. For example, listen here. So, for example, see, K equal to 1, it should be critical damped. So, critical damped means what? Tell? Critical damped means what? Two poles should be repeated at the same location. What is GH tell? GH equal to K by S into S plus 2. I'll substitute K equal to 1. K equal to 1 means what is GH tell? GH equal to 1 by S into S plus 2. Which poles? These are closed loop poles. Root locus gives the closed loop poles path. It never gives open loop poles path. Closed loop poles given by characteristic equation 1 plus GH 0. Now what I will get? What is the characteristic equation? S square plus 2S plus 1 equal to 0. So this can be written as S plus 1 whole square equal to 0. S equal to what? -1 minus 1. Is it critical damped or not? 100% it is critical. Or you find here zeta omega n1, zeta equal to 1, system is critical damped. Automatically it will be satisfied these conditions. Automatically K equal to 1, critical damped. You take any value of K greater than 1, it is going to become what? Underdamped system. K greater than 1, underdamped. So for example, you take K equal to 2, you take for example. K equal to 2, you take for example. The system should be underdamped because greater than 1. So K equal to 2 means what is GH tell? 2 by S into S plus 2. What is the characteristic equation tell? So S square plus 2S plus 2. S square plus 2S plus 2. What is S tell? -1. Real part is -1. Imaginary part may be any value. -1 plus or minus J1. It is underdamped or 100% it is underdamped. You take K even 100 also underdamped only. K 100 you take for example. K 100 means what? S square plus 2S plus 100. S square plus 2S plus 100 means what are the roots tell? -1 plus or minus J root 99. Minus real part -1, it never change. Imaginary part only along this. Imaginary part only going to be changed. It may be minus plus J1, it may be plus J99 or it may be plus J infinity. System is going to become what? Underdamped. System is going to become underdamped. So that means you take any value of K greater than 1, the system is underdamped. So is this closed loop poles path or open loop poles path? It is a closed loop poles path. RLD, root locus diagram, gives closed loop poles path, but not the open loop poles path. Closed loop poles path, be remember. RLD gives closed loop poles path. It is not open loop. We are taking GH to calculate all the factors. After calculating, if you draw the RLD, that is a closed loop poles path because all the rules are framed by taking 1 plus gh equal to 0. By taking characteristic equation only, we formed the rules. Angle condition, what we taken? 1 plus gh. So that's why by default you will get the what? Closed loop poles path. So root locus diagram gives the closed loop poles path. That's all. Next, one more thing here. One more thing you should know. Sometimes they used to ask it. What they used to ask? Find the k value. So write it question. What they used to ask? Find the k value. Find the k value to operate system. To operate system with a damping ratio of 0.707. Like these questions they will ask. What is the k value to operate system with a damping ratio of 0.707? They will ask. Like this they will ask it. Then how to find the k value to operate with some particular value of zeta? So first step here, so zeta equal to what? Cos theta. Zeta equal to cos theta. I told in the time domain analysis. Theta equal to cos inverse zeta. So that means what? Cos inverse of 0.707. How much tell? Theta equal to 45 degrees. Theta equal to 45 degrees. You draw a line with the angle of 45 degrees. You draw a line with the angle of 45 degrees. You draw a line with the angle of 45 degrees like this. You draw a line with the angle of 45 degrees. This is the angle of what? 45 degrees. 45 degrees. It is the angle of 45 degrees. Now at this point, this is point P for example. At point P, you have to find the k value. At point P, we have to find the k value. At point P, we have to find the k value. Now, how to find? You find this location first of all. So, our product of lengths we can use. You find the length up to this. See, for example, what is this length? Tell 1 unit. What is this length? So, 45 degrees means tan 45 equal to tan 45 equal tan theta equal to y by x na? Y by x, dy by dx we used to write simply y by x because one point is 0. Y by x, tan 45 1. That means y equal to y by x equal to 1. So y equal to x. That means this distance also 1 unit only na? This distance is 1 unit. This 45, tan 45 1 means the distance of x equal to distance of y. That means this length also 1. What is this diagonal? And find this distance also. This distance also you have to find. This distance also you have to find. This distance also you have to find. Find the distance. So this distance is how much? Tell 1 unit. Now tell what is this diagonal distance? 1 1. This distance is root of a square plus b square means what? Root 2. Even this distance also what? Root 2. Now find at point P. At point P. So what is k value? Tell k equal to product of lengths point to pole. Point to pole how much? Root 2. So here point to pole how much? Root 2. So there is no zeros divided by 1. So what is the k? 2. K equal to 2. If you select k equal to 2, it is operated with a damping ratio of 0.707. If you have any doubt, k2 you take and find zeta value. Gh equal to what? 2 by s into s plus 2. Now write characteristic equation 1 plus gh 0. So that means how much? Tell what is the characteristic equation? S square plus 2s plus 2 equal to 0. Find zeta. You find it. Omega n equal to root 2 radians per second. Find zeta. No doubt you will get 0.707. 1 by root 2 you will get 0.707 you will get. So like this you have to find the k value. Like this you have to find the k value at for required damping ratio. For required damping ratio. Okay. So this is the complete analysis of the root locus. Complete analysis. Finding range of k value. finding the k value for different natures, finding the k values for zeta. So this is a complete analysis. Okay, na? So one more problem. Next problem. I hope you got it. Next problem. Come on, you solve it. Repeat the problem. Come on. Draw the RLD. K by S into S square plus 2S. Come on, do it. Come on, Bhaiya. Come on, come on, come on. Today you read all these questions. I'll give some problems homework. For all that problems, you find just breakpoints, angle of departures and arrival. So that tomorrow we can solve the problems quickly. And generally any 2 marks question they are asking on root locus diagram directly means that will be generally breakpoints, direct 2 marks, there will be on breakpoints and angle of departures and arrival. So these two are very, very important. Come on, do it. First, identify real axis, root locus branches and breakpoint. One pole at origin, K0, and there are the complex poles, -1 plus or minus J1, I think. -1 plus or minus J1, here K equal to 0. Here K equal to 0. Here, is there a root locus branch here? No, but here there exists a root locus branch. There exists a root locus branch. Next breakpoint you find. Breakpoint d by ds of 1 by s cube plus 2s square plus 2s equal to 0. Come on, u dash 0 minus u into v dash 3s square plus 4s plus 2. Find the roots. Find the roots for the equation. I think you will get minus 0.6 plus or minus j 0.4. Right. Come on. So here this is invalid breakpoint. It is invalid breakpoint. Complex breakpoints are exist actually. Complex breakpoints also valid. But here it is invalid. How can I say means listen. Complex breakpoints are valid only one case. Complex breakpoints are valid. Yoru? చెప్పండి రెడ్డి చెప్పు గుడ్ ఆఫ్టర్నూన్ చెప్పు ఫ్రైడే రోజా సరే సరే సాటర్డే కూడా వేస్తున్నావా ఈసారి సాటర్డే హాలిడే ఇవ్వాల్సినవు కంట్రోల్ చేస్తున్నావా 1 to 9 అడుగుతాను మళ్ళీ ఒకసారి అడుగుతాను అడిగి చెప్తాను ఓకే 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 ఎప్పుడు ఫ్రైడే సాటర్డే సండేనా 1 to 9. Sorry, okay. Right. So complex breakpoints are valid only. Complex breakpoints. Complex breakpoints are valid only. Complex breakpoints are valid only when the given point, when the complex breakpoints are valid only when the real part of the complex pole, when the real part of, listen carefully, when the real part of complex breakpoint should be equal to real part of complex pole. Real part of complex pole. Real part of complex pole. So read this statement one more time. Complex breakpoints are valid only when the real part of complex breakpoint should be equal to real part of complex pole. What is the real part of complex breakpoint here? Minus 0.6. Real part of complex breakpoint, how much you got it? Minus 0.6 na? What is the real part of complex pole? This is the complex pole. What is the real part? Tell. Minus 1. Both are equal or not equal? Not equal. That's why it is not a valid breakpoint. Here real part is minus 1. Here real part is minus 0.6. That means both are not same. So it is invalid breakpoint. In case here minus 1 plus or minus j 0.4 is there. Here minus 1 is there. No doubt this complex breakpoint is going to be valid. No doubt this complex breakpoint is going to be valid. Otherwise, it is not valid. Be remember. So the complex breakpoints are valid only when the real part of complex breakpoint should be equal to real part of the complex pole. Then only it is valid. Be remember. So complex breakpoint is not valid. So breakpoints are not exist here. Next, step 2. This is step 1. So is it possible to attend the class 1 to 9 on Friday, Saturday, Sunday? Is it possible? Give the response.
No,
Is it possible to attend the class 1 to 9 Friday, Saturday, Sunday?
sir, we have exams, sir.
Exams. Exams are there. Okay.
On what date, sir? On what date?
This Friday, Saturday, Sunday.
So, exam ఏ రోజు ఉందో అడగండి సార్.
Which exam?
Saturday.
Saturday,
ఉంది,
sir.
sir.
Friday, okay. Is it okay on Friday?
Sir, but preparation కావాలి కదా, sir.
అదేం కదండి. హలో,
సరే సార్ చూద్దాం సార్.
సరే ఓకే. రైట్. Next, listen, all of you listen. So complex breakpoint is invalid. Next, come on. Next, step 2. What is step 2? Tell. Calculate angle of asymptote. Number of asymptotes equal to P minus Z. P minus Z equal to what? 3 minus 0 becomes 3. Angle of asymptotes theta. 180 by P minus Z. 180 by P minus Z. P minus Z is 3. 180 by 3 is 60 degrees. So product with odd number. 60 into 1, 60 only. 60 into 3, 180. 60 into 5, 300. So the angle of asymptotes is 60. You have to multiply with odd number na, into 1, into 3, into 5. So 60 into 1, 60 only. 60 into 3, 180. 60 into 5, 300. Next, centroid. What is the centroid? Tell. Centroid you find. Centroid is sum of real part of pole. What is the real part of pole here? Minus 1. This real part of pole minus 1. This real part of pole minus 1. No zeros. Divided by P minus Z is 3. So that means minus 0.66 is the centroid. Centroid is minus 0.66. Next, last step. Here, one more thing. Complex poles are there. That means we require to calculate angle of departure. Calculate angle of departure. Come on. Angle of G of S, H of S. Where to calculate? Tell. Minus 1 plus or minus J1. Minus 1 plus or minus J1. So, angle of GH at S equal to minus 1 plus J1 you calculate. That is angle of departure I am calculating. AD means angle of departure. Angle of departure. Angle of departure. Now come on, calculate angle of K by angle of S. Angle of S plus 1 minus J1. Angle of S plus 1 plus J1. So come on, calculate. Angle of K. Angle of S is minus 1 plus J1. Angle of here minus 1 plus J1, if you substitute, what I will get? Minus 1 plus J1 means 0. Here substitute minus 1 plus J1. Minus 1 plus 1 cancel. That means plus J2. You should be perfect in calculations of angle of departures, arrivals and breakpoints. Simple substitution only, na? Substitute and get the answer. Angle of K 0 degrees. Angle of minus 1 plus J1. Minus 1 means minus negative real axis. Minus means negative real. Plus J1 means positive match. That means second coordinate. What is the angle for second coordinate? 180 minus tan inverse of imaginary part by real part. So use 180 minus tan inverse of what is the imaginary part 1? What is the real part 1? So this is the angle. Plus 0 degrees. Plus J2 means 90 degrees. Now tell what is the answer? 0 degrees by. So 45. 180 minus 45 means 135 degrees. 135 plus 0 plus 90 degrees. So the answer is minus 225 degrees. Answer is 225 degrees. Then pi d. What is the formula pi d? 180 plus angle GH. So that means what you are getting? 180 minus 225 degrees. That means how much? Minus 45 degrees. So angle of departure, pi d, finally what it is? Minus or plus 45 degrees. This is the angle of departure. This is the angle of departure. Now draw the root locus diagram. You have to draw the root. Any more thing required? So we required even intersection point with imaginary. Whenever angle of asymptotes you are getting 60, 60, 45. 60 means right side only, na? With respect to 0 degrees, 60 means right side. Means it is intersecting imaginary axis. 60, 45, less than 60 is there, less than 90 is there. Less than 90 degrees is there means that plot intersect the imaginary. So we require to find intersection point with imaginary. Or poles right to, zeros left to. Then also we have to find intersection point with imaginary. Calculate intersection point with imaginary. So intersection point with imaginary. Intersection point with imaginary. It is third order system. No, directly we can write. Intersection point with imaginary. Intersection point with imaginary. So what is the characteristic equation? Tell. 1 plus GH equal to 0. So then, bolo, S square, S cube na, S cube, plus I think 2S square, plus 2S, plus K equal to 0, I think. 1 minute. Yes, correct. Come on. S cube plus 2s square plus 2s plus k equal to 0. Now tell internal product equal to external product. Internal product equal to external product. That means k marginal equal to 4. Frequency of oscillation simply root 2 plus or minus, or even power of s terms 0. Frequency of oscillation or intersection point means even power of s terms. Intersection point. IP means intersection point. So even power of s terms 0. Only for third order. Even power of s terms 0. Already I told in the RH also. Even power of s terms 0. So that means what? 2s square plus k. K is called k marginal 4. K is called k marginal. K is called k marginal. You have to consider. Or write k. K equal to 4 again. K. K is 4. Then what happened? 2s square plus 4 equal to 0. 2 1 ja 2 4. 2 2 ja. Then s equal to what? Plus or minus j root 2. This is the intersection point. Intersection point with imaginary plus j root 2 plus or minus j root 2 and k marginal is 4. Now draw the root locus diagram. You draw the root locus diagram. One pole at origin. One pole at minus 1 plus or minus j1. K equal to 0, k equal to 0, k equal to 0. So now come on, find the, draw the root locus. Here there exists a root locus branch. Now centroid, what is the centroid we got? Centroid we got is minus 0.66 we got. This is the centroid. Centroid minus 0.66. Draw the angle of asymptotes. What are the angle of asymptotes? One is 60. The second one is 60. Second one is 180. Third one is 270. This is j omega axis. Come on, draw the angle of asymptotes. Angle of asymptotes. 1 minute. I'll reduce this length. Plus j1. Here k equal to 0. Now draw it. This is what? This is the angle of how much? 300. Next to draw 60 degrees. Actually, you have to draw by using the what? Protractor. In the exam, if it is a IES conventional, you have to draw by using protractor. For objective, it is not required. Like this. So now this is the 60 degrees. Along the 60 degrees, there exists a 0 where k equal to infinity. Along 180 degrees, there is a 0 at minus infinity. K infinity at 180 degrees. Along this is 300 degrees. Along 300 degrees, there is a 0 where K equal to infinity. Where K equal to infinity. Now tell 3 poles and 3 zeros. This is 1 pole, this is 1 pole, this is 1 pole. 3 poles, 3 zeros. Now we have to draw the root locus diagram. So here there is no break point. So that's why this pole, whatever the pole is there on the real axis, simply it will go on, moves toward the left. It will go on, moves toward the left. It occupies the 0. It occupies the 0 when K equal to infinity. That's all. One pole gone. This pole should be depart with the angle of what? This pole. What is the angle of departure you got? Minus 45 degrees. So you depart with minus 45 degrees. This depart with angle of plus 45 degrees. This depart with the angle of plus 45 degrees. Angle of departure. And it should be intersect at a point of what? Plus j root 2. It should be intersect at the point of plus j root 2. We'll make it. Okay, no problem. Sorry, okay, no problem. Here plus j root 2 I'll take. Plus j root 2. Where K equal to 4. So here minus j root 2. This is minus j root 2. Where K equal to 4. Where K equal to 4. So what happens as K increases, this pole moves near to asymptote and parallel to asymptote. Enter, intersect the imaginary axis at where? Plus j root 2, plus j root 2 and occupies the zeros. The pole moves near to asymptote, parallel to asymptote, enter into asymptote and occupies the zeros. This pole also same, near to asymptote, parallel to asymptote, near to asymptote, parallel to asymptote, near to asymptote, parallel to asymptote, enter into asymptote and occupies the zeros. Near to asymptote, parallel to asymptote, enter into asymptote and occupies the zeros. And occupies the zeros like this. So near to asymptote, parallel to asymptote, enter into asymptote and occupies the zeros. This is the root locus diagram. So 3 poles reaches the 3 zeros. So when it is stable, tell, when it is stable, K equal to 0, it is not stable because pole on imaginary axis. K greater than 0, it is stable because poles come to left. This is also in the left. This is also left, stable. As K increase, this pole goes to left. We don't have any problem about the real axis pole. But these imaginary complex poles are moving toward the right. Complex poles are moving toward the right. When it is coming to imaginary, 4. That means K greater than 0, less than 4, the closed loop system is stable. K here 0, here 4, greater than 0, less than 4, the system is stable. K equal to 4, the given system is what? Marginal stable. K equal to 4, the given system is what? Because K equal to 4 means poles coming on what? Imaginary axis. So K equal to 4, system is marginal stable. Next, one more thing here. What are the different natures the system is having? Different natures. Overdamped not there because no 2 poles on the negative real axis, no overdamp, no breakpoint, no 2 poles meet on the negative real axis. That means no critical damp. But this nature is what? This distance is what? Underdamped. This is under complex conjugate. Na? Complex conjugate means what? It is underdamped. Here underdamped. This is underdamped. Underdamped. At this point what? Undamped. At this point undamped. Undamped. At this point what? Undamped. Undamped. That means the system having the what? Underdamped nature. What is the range of K for underdamped? What is the range of K for underdamped? Anybody? So here what? 0. Here what? 4. That means K greater than 0, less than 4. The system is underdamped system. Underdamped system. Don't put equal to, because K equal to means this pole at origin. Then it is not stable. That is the problem. That's why K greater than 0. It is left. Then complex poles are at this point. So that it is underdamped. Because one single pole on the real axis, complex poles are there. We'll consider only complex pole response. That's why K greater than 0, less than 4, underdamped. K equal to 4, the system is undamped system. The system is undamped system. Undamped system. That's so this is completes the problem. So I'll give some homework problems. You solve it, all of you. Just to find breakpoints and angle of departure. Find breakpoints and angle of departures. Angle of departures. For these problems, you solve it so that next we can move little bit fast. Not only that, you have to practice. S plus 4. Use the calculator and get it. So there is a concept. Actually, they don't ask this much big problem in the gate, no doubt. But there is a concept, one concept. On that, there may ask the theory question. But that concept you want to explain, I need to take real poles and complex poles. That's why the order I cannot reduce. S plus 1, S square, 2S plus 2. Third, GH equal to K by GH or GH of S, both are same. S plus 2, S square plus 2. K by S into S plus 2 into S square plus 2S plus 1.25. GH equal to K by S into S plus 2 into S square plus 2S plus 10. Last problem. GH equal to K by S into S square plus 6S plus 10. For these 6 problems, you find a breakpoints, angle of departures. Okay. I'll close here. If you have any doubt, you can ask. Akans. Tell man, tell.
Hello.
Tell.
Sir, in the last question where you the angle of departure, you have calculated angle of departure.
Calculated here, na?
Yes, sir. Okay, sir. So I did some mistake. Okay, sir.
Okay. Abdul.
సార్ ఇది ఇక్కడ కింద యాంగిల్ ఆఫ్ డిపార్చర్స్ దగ్గర మీరు ఎస్ ఈక్వల్ టు -1 ప్లస్ J1 తీసుకుంటున్నాం కదా, కానీ ఇక్కడ మళ్ళీ వాల్యూ యాంగిల్ ఆఫ్ ఎస్ లో ఎస్ అది కూడా ఎస్ సేమ్ రావాలి కదా సార్. మీరు ఇక్కడ S + 1 J1 ఎలా తీసుకున్నారు సార్? అలా రాదు కదా.
Where is the pole? What is this pole location?
పోల్ లొకేషన్ కాదు, నేను పోల్ లొకేషన్ అనట్లేదు సార్. మనం అది డివైడ్ చేస్తాం కదా సార్. ప్రాబ్లం సార్.
Substitute S by -1 plus J1.
కాదు సార్, అది కాదు సార్. ఇది 1 - J1 అంటే S² + 2S + 2 అంటే -B + 4AC - B² తీసుకుంటావా, లేకపోతే ప్లస్ ఆర్ మైనస్ అది తీసుకుంటావా సార్?
What you are asking, man? Roots you are asking,
రూట్స్
-B plus or minus root of B square minus 4AC by 2A కదా.
అదే, కానీ ఇక్కడ మీరు ఇక్కడ ప్లస్ పెట్టారు కదా సార్, అందుకని డౌట్ వచ్చింది.
S equal to -1 అంటే what you will write? S plus 1 only, na?
ఓకే.
Yes or no?
ఎస్ సార్, అదొకటే ఆన్సర్.
సరే. Susmita.
Sir, good evening, sir.
Good evening, చెప్పమ్మా.
Sir, 17F, sir.
this only, amma.
ఇది సార్ మా ఇంత కాంప్లెక్స్ గా లేకుండా డైరెక్ట్ గా మనము క్యారెక్టరిస్టిక్ ఈక్వేషన్
But if
రాసుకొని
third order gives, then what you will do?
ఓకే ఓకే సార్
First,
After
second
ఈ
order,
procedure
okay.
follow.
Third order, what you will do? Third, fourth, fifth.
ఎస్ సార్
Second, first, second order, we can do with characteristic equation.
ఎస్ సార్
Okay. Next, Susma.
Hello,
Tell.
sir. In the same page, once you explain that last part, sir. We
What
took
is your
the
doubt? You tell last part means K value.
I didn't understood that angle 45.
Cos 0.707, how much? They given zeta value na in the question.
Okay.
Zeta given in the question. Cos inverse of 0.707, how much?
45. After that, sir.
After that, product of lengths. From this point, you find the length. What is this length? √2 na?
Okay.
This length is 1 unit. This length also 1 unit na. 45 degrees means x equal to y.
Okay.
1. This is √2. This is √2. √2 into √2 na.
Okay, sir.
Okay na?
Okay, sir.
Okay. Mohit.
Yes, sir. Audible, sir.
Tell me.
Sir, here, sir, we are for the zeros and pole location. It is dependent on value of k.
What? One more time you tell.
Sir, zeros and pole locations are dependent on the values of k.
Zeros and poles location depends on k. Yes.
Sir,
Not zeros, poles position.
So
Zero
initially,
position fixed. That is k equal to infinity. That is fixed.
yes, sir. So
Pole
initially,
position depends on k.
yes, sir. Initially, when you solve any problem for the root locus, you find poles from G into H.
Yes.
Sir, at that k is equals to 0 now, sir.
K equal to 0, open loop poles equal to closed loop poles.
So because earlier we used to find from characteristic equation, that's why little
Here
down.
also root locus gives the closed loop poles path. What I written here, RLD gives closed loop
Yes,
poles
sir.
path. We verified now here k equal to 2. Which poles we got?
Yes, sir. So that point only I got clarity. Yes, sir. That's
Root
right.
locus rules we framed by using what? Characteristic equation, na?
Yes, sir. Yes, sir. Right.
That's why it gives the closed loop poles path.
Yes, sir. Thank you.
Okay.
Yes, sir. Thank you.
Karthik,
Hello, sir.
tell.
Am I audible? Yes,
tell.
sir. How to calculate time constant for second order system, sir?
Based on the zeta, na? I told already in the time domain analysis 1 by zeta omega n for underdamped. For overdamped 1 by zeta omega n minus omega n root of zeta square minus 1. Already I discussed, na? You
Okay,
refer
okay,
one
sir.
time domain
Fine.
analysis.
Okay, sir. I will do it. Thank you.
Okay,
Sir.
na?
Sir, what is the exam? Sir, what exam do you have on Saturday? Someone was telling that.
They are having university exams. Some college goer students are there
Oh.
in this batch. They are having some mid exams, I think. Not
Sir,
conducting AC
if
exam.
not many people have, okay. If not many people having the exam, then you can ask to conduct others.
Okay, we'll see what they decide, the manager. Okay.
Okay. Sir.
Susma completed, na? Susma over, na?
Yes, sir. Yes, sir. Completed.
Okay, ma. Okay.